Severe G4 geomagnetic storm sparks jaw-dropping northern lights around the world. In a spectacular cosmic show, Earth was recently treated to some of the most vivid and widespread auroral displays in years after a severe G4 classified geomagnetic storm buffeted our planet's magnetic field. This intense space weather event created breathtaking northern lights, aurora borealis, that dazzled skywatchers from high latitudes down into regions where such displays are rare, a testament to the power of solar activity and the dynamic interaction between the sun and Earth's magnetic shield. What triggered the storm? The stunning auroras were caused by a geomagnetic storm, a disturbance in Earth's magnetic field triggered by a coronal mass ejection, CME, from the sun. A CME is a massive burst of solar plasma and magnetic field that blasts outward from the sun's corona. When these high-energy particles reach Earth, they can interact with our magnetic field and upper atmosphere, energizing atoms and molecules and creating the shimmering auroral lights. This event was strong enough to reach G4 on the NOAA geomagnetic storm scale, which ranges from G1 minor to G5 extreme. A G4 storm is classified as severe, indicating powerful disturbances in the magnetosphere. Why the northern lights spread so wide? Under normal conditions, auroras are typically confined to high latitudes near the poles. During strong geomagnetic storms, however, the auroral oval, the ring of auroral activity around Earth's magnetic poles, expands toward lower latitudes. This means people far from the Arctic Circle found themselves under electrifying skies that night. As a result, spectacular green, pink, and sometimes red auroras were captured in many parts of North America and Europe, even in areas that rarely see them. Some photographers also reported shots from places farther south than usual for aurora sightings. Photographers and pilots catch the action. Citizen photographers and professional enthusiasts alike took to social media and photo galleries to share striking images of the sky ablaze with color. In some cases, pilots cruising at high altitude were treated to an aerial view of the auroras, a rare phenomenon usually visible only from the ground or space. Photographs from this storm ranged from delicate, dancing arcs to broad curtains of light filling the night sky, each capturing the dynamic beauty of charged particles spiraling along magnetic field lines and colliding with atmospheric gases. Beyond the lights, why it matters. While auroras are a breathtaking spectacle, severe geomagnetic storms are more than just pretty lights. They can also have practical consequences. Satellite operations can be disrupted as charged particles interfere with electronics and signal transmission. Radio communications may experience degradation or outages. Power grids can be stressed in extreme cases, especially at high latitudes where geomagnetic-induced currents are stronger. Scientists and space weather forecasters keep a close eye on solar activity precisely because strong storms like this can have real impacts on technology and infrastructure. What comes next? The sun is currently in a period of elevated activity as part of its roughly 11-year solar cycle. This means more dramatic auroral events are possible in the near future, especially as the sun approaches and moves past its solar maximum, when flares and CMEs become more frequent and intense.